Okay, yeah, there's an extra. 8.3, surface area and volume of prisms and pyramids. Okay? We're going to start with a few notes in that top part of your page. If you want to, you can write your notes across. Otherwise, you can use like a block for one note, a block for another note, a block for another note, a block for another note. There's going to be 4 notes. Okay? Some of them will be words you already understand, and that's good. Here we go. First note is on surface area. Surface area. This is the number of square units. The number of square units needed to cover the surface of a 3D object. Okay? Surface area is the number of square units needed to cover the surface of a 3D object. So that means we're thinking about these unit tiles. Okay? How many of those are needed to, let's say, cover, don't draw this, but if we were going to cover a cube, okay, you'd say, okay, it's 4 across, and it's 4 this way, and it's 4 deep. Okay, and then you'd say, okay, how much does it take to cover this face? And there are 6 faces, so I multiply that by 6, and that's how much it would take to be kind of the skin of the object, go all the way around all the surfaces of the object. Good. Next one is volume. This is the amount of space that an object occupies. The amount of space that an object occupies, and we need to note that it is measured in cubic units. So it doesn't matter if you're talking about centimeters or kilometers or miles or any other kind of measurement tool that you want to use. This is going to be measured in cubic units. So it would be with that with some kind of box. It would be, this is taking up so many cubic centimeters, right? Good. The next word that you have is pyramid. I'm going to be dealing with prisms and pyramids today. A pyramid, this is a polyhedron. It's just a name for this group of objects, 3-dimensional objects, whose base is a polygon. Whose base is a polygon, and whose faces are triangles that meet at a vertex. So go ahead and picture in your mind a pyramid. You can kind of see, yep, the base is a polygon. It might be a triangle, it might be a square, it might be any polygon, it might be a nonagon, right? As long as the other faces, the lateral faces, are triangles that meet at a point. And they always will be. If you put same triangles together, they'll meet at a point. Okay. And the last thing that we're talking about is lateral faces. So a 3-dimensional object, a prism, will have lateral faces. So these are the faces of a prism or pyramid that are not bases. Okay, so you are going to get good at drawing some of these shapes and things like that. But for instance, do you have a little bit of space to draw me a little picture? So go ahead and draw yourself, not a cube, but a rectangular prism. And if you're not sure how to do that, you can copy my steps. Again, we're going to do diagonal lines and make sure each of these 3 diagonal lines is the exact same length. And then this line should be parallel and the same length as these other lines. And this horizontal line should be parallel and the same length as this horizontal line. And then you've got a pretty decent rectangular prism. Now, that means that this and this are called lateral faces.
They have to be exactly the same.
No, as long as they're, well, they will be, except in a pyramid. Well, yeah, they will be, really. And this guy is called, do you know what that's called?
Base.
Okay, so they're all faces. There are 6 faces on this rectangular prism. The top and bottom ones are called bases. Okay, there are 2 bases on this prism, and there are 4 lateral faces. But there's 6 faces altogether. 2 of them are called bases. 4 of them are called lateral faces. Okay, if you were to draw a pyramid is a little bit tougher. You don't necessarily need to try this. Okay, this pyramid, because it has a square base, it has 1 base right there, and it has 4 lateral faces that are triangles. Okay? With that, let's head into our investigation. Okay? A net is a drawing. If you were to kind of peel back the faces of a prism or a pyramid and lay it all flat, like the skin of it, you kind of peel it off and lay it flat, that would be called a net. Okay? So that first picture there is a net. Of what shape would that be? What object would that make?
A triangular
Square pyramid.
It would make a square pyramid. Okay, so it's a pyramid because those triangular lateral faces are all gonna, slap up and meet together at a vertex, and the base is a square. So it's a square-based pyramid. If you're not sure about that or you didn't know that right off the bat, then just jot that down. Square-based pyramid. Okay, good. How many bases are there? 1 base. What is the shape of each base? Square. How many lateral faces are there? 4. What is the shape of each lateral face? Excellent. Step number 2. There's another net shown. Except it's actually not a net. It's the whole thing. It's not a net at all. It's just the 3-dimensional object. So I'll need to change that. How many bases are there? 2. What is the shape of each base? Pentagon. So this is a pentagonal prism. Okay? C. How many lateral faces are there?
5.
Yeah, there's got to be 5 because there's 1 for each side of the pentagonal base. And the last one, what is the shape of each lateral face? Rectangle. Whenever you're making a prism, the lateral faces will always be rectangles. Okay?
Isn't a rectangle square, but a square isn't a rectangle or something like that?
What?
Every square is a rectangle, yes, but not every rectangle is a square.
Really?
Yeah, a square is a special rectangle. Okay, excellent. Let's carry on, guys. We're going to try to crush out 2 lessons today, so please stick with it and pay attention. Example 1. Does anyone know what's in the picture without reading the reading? Yeah, it's a famous museum in Paris. Good. A modern example of a pyramid can be found at the Louvre in Paris, France. The glass, square-based pyramid is the entrance to this famous museum. Calculate the surface area of the pyramid, including the base area. So what are we talking about when we're talking about surface area?
Length times width, height,
Length times height? No,
divided by 2.
The base times height, or half.
Base times width times height.
Number of square units needed to cover the surface of the cube.
Nice. Okay, so in this case, the surface area includes... Yes, please. The square base and... What else? How else would I say the next part?
4 triangular shapes.
And the 4 triangular... What are they called? What kind of faces are they? Lateral faces. Okay, so again, I could do that all separately. This one's small enough that I'm going to do this just all together. I'm going to take the surface area of the pyramid is equal to the area of the base. You could say surface area of the base. You don't really need to because it's just the area of the base is the area that it takes up, length times width.
Would it be like for the area of the base? Would it be 27.8 times 35?
Not for the base, no, because the base is a square, so its length and width are going to be the exact same
I know, but
length.
the
So
length of that, or the height of that triangle, isn't the height of the
So you
square.
would do
35 times
35
the
times
triangle
35.
is not related to the
No,
square
it's
except that they're
35 times
attached.
two.
The height of the triangle doesn't make any difference to the square. You might have the same square base with a really short triangle or a really tall triangle. Right? So those numbers aren't related, but we'll get to it. Let's work through it step by step. And we have 4 times the area of the triangle. Now, do I need to calculate each triangular face independently? No. Do 1 and times it by 4. All right, here we go. So the square base is quite easy. What are the dimensions of the square base?
35.
So it has a length of 35. What's its width?
35.
Also 35. It's a square.
No way.
Okay? So the area of that is just length times width. 35 times 35. Excellent.
That's square.
Now watch how we write this part, guys.
Oh.
We're going to just keep that 4 out there, and we're going to put the area of the triangle inside brackets, okay? What's the area of a triangle again?
1/2 base.
1/2 base times height. Do we know the base of the triangle?
Yeah.
Yes.
35.
Thank you. Do we know the height of the triangle? Yes.
27.
And I close that off with a square bracket. Now just some careful things in your calculator. Everyone should have their calculator out. Punching away, 35 times 35, or 35 squared.
1,225.
1, 2, 2, 5. And now over here, it's a little bit trickier. Here's what I would do. I would do 35 times 27.8. And then you can either divide that by 2 or multiply it by 0.5.
486.5.
And then multiply it by 4.
1,946.
Should have gotten it.
Is 6,840.
You should have gotten 1,946 for that part. And then to get the surface area of the pyramid all together, we just finish it out by adding all of that together.
3,100.
And now we think about the units of measurement that we need.
Meters.
Meters squared.
Meters squared. Good job.
Oh wow.
We're learning.
The surface area. Yes, every word problem needs to be finished off with a concluding statement. The surface area of the pyramid is 3171 meters squared. All right, looking at are we good here with this? Do I need to walk through this again?
Was the
Wait, meters
pyramid
square?
a
Yeah, you
3D
can walk through
object?
it.
Yes.
Surface.
So it should be cubed.
We're not calculating volume, calculating
Yeah,
area.
but it says surface area, and I'm not going to need it. Oh yeah, wait,
Cover
never mind. Okay, all right.
Squared.
Right.
Yep.
Are we
Good.
doing volume today?
Example 2, volume of a pyramid. All right, here we go. So you have a little diagram there, and we are going to determine the volume of the pyramid-shaped container to the nearest cubic centimeter. So pay attention, they already told you what your final answer is going to be, and it's going to be in cubic centimeters or centimeters cubed, okay? And then we're going to express that capacity in liters. That part is a little bit tricky, so we'll worry about that when we get there. But does anyone know the formula for the volume of a pyramid?
Length times width times height. Maybe. I don't know. Maybe just base times height.
1/2 base times height.
All right, you should be writing this. Volume equals, it's 1/3
Oh yeah. Oh.
the area of the base times the height. Okay, it's a bit of a tricky one to memorize.
Could you just write B and H?
But we have a pyramid-shaped container. So we're taking 1/3 the area of the base and multiplying it by the height. Okay? So first things first, do we have the height of the pyramid?
Yes.
No.
Ooh, there's a thing in the middle.
We have the slant of the pyramid. We have the length of the slant. We do not have the actual height of the pyramid from the center of the pyramid up.
B squared plus B
Okay.
squared equals C
Will this
squared.
be
So if we kind of,
Sneaky cheat.
yeah, you're right, we need the Pythagorean Theorem. So basically what we have is a diagram like this, right? And if we cut that pyramid in half, we know that it's 10 centimeters to get up the slant of it, and we know it's 8 centimeters across the base of it, but we actually need this right here. We actually need the height.
Equals C squared.
Excellent. So we're going to get the height by using, I'll say, first use
Pythagorean Theorem.
Pythag theorem
Python.
We saw Python at the same.
to find the height. Okay? Now, what else do I need to remember when I'm using h squared equals a squared plus b squared?
Nothing. Well, something.
Oh, sorry, it's not. I did it wrong already, didn't I?
C squared.
It's a squared minus
This.
b squared.
This is this is the hypotenuse, right?
Minus.
Yes.
So if we were going to set it up, we have
I am
10 squared
You're dead.
equals h squared plus, does anyone know the last part?
8 squared. 8 squared.
Four
Is it
squared.
8
Four
squared?
squared.
Why is it 4?
This is in the half. It's H squared.
Because I only have half of that base, okay? So 4 squared. Good. Here we go. What's 10 squared? 100. We don't know h squared. What's 4 squared? 16. Sammy, how do I isolate h?
You have to minus 16 from the right side. And minus it on the left side.
Excellent. I'm going to take 16 away from both sides. That's going to leave me with h squared equals 100 minus 16, anyone?
84.
84.
Wow, other
Next step to get h by itself,
Square root it.
take the square root of both sides.
than H by itself.
And the square root of 84 is approximately.
9.1.
Anyone else want to see it?
So let's round just to one decimal place there. And I know this isn't the final answer, but just so I can keep track of where my help is coming from, where my answers are coming from, I'm going to box this h equals 9.2. Okay, now calculate the volume of the pyramid. If you're not sure how we got this 4, you can also make a note here. This is
You just divide
Half.
by half.
the base. And we get the volume of the pyramid now. Okay, so we have our formula up top. I'm going to copy it down. Volume is 1/3. And now to get the area of the base, well, I'm looking at this thing and it is a square-based pyramid. So how would I calculate the area of the base?
Base times height.
Length times width, right, of the base. So the sides of just 8 times 8. And the height we calculated as 9.2. All right. You could also use 8 squared in here.
So 64 times 9.2.
Yeah, you could do this all in your calculator. Kind of do 8 squared is 64 times 9.2. How would you do this times 1/3?
Divide by 3.
Divided by 3. Nice. And the volume is approximately rounded to the nearest,
Wait, what do you do when you have-
196.3.
What do you do when you
rounded
have
to the nearest
580?
cubic centimeter.
3. Oh, sorry.
Okay?
Oh, volume is easier than I thought.
What happens when you have
So you've done
588?
8 squared times 9.2.
Yeah.
You still need to multiply it by 1/3.
Oh, you multiply it? How do you
Well, hold on,
multiply
hold on.
by
Divided by
1/3?
3.
Multiplying by 1/3 is the same as dividing by 3. Okay?
Divide by 3.
Good. Now, we're not done because there's B.
Blue.
So let's read B again. B says to express this volume, this capacity in liters. Okay, this is pretty tough. The capacity is the maximum amount that this container will hold. Okay, so when the product is packaged, it's usually not filled to capacity.
Like chips.
But for this one, we don't, like chips or pop
You get
or
half
whatever.
big. Pop is filled to the rim.
Pop is pretty full. Yeah, Gatorade is filled right to the brim. You open it, it spills. Anyway,
Oh, those little fruit snacks, and you open it, and every time you get it all.
yeah.
Yeah.
Yeah. Okay, so here we go. Ladies and gentlemen,
That's because you don't open
Some people have to do it.
one, we're making a conversion. Hello.
Regroup.
I'm giving you a conversion from volume, like space, to liquid volume, okay? So we're going to do this capacity in, we need to convert it to liters, right?
What's that
Well,
for?
here's the rule, is that 1 cubic centimeter,
Equals 14.
you fit 1 milliliter in a cubic centimeter. So if you had a tiny little cube that was a centimeter on each side and you filled it with water, you'd have 1 milliliter of water. Okay?
How many milliliters are in a liter?
Well, yeah, so here we go. How many milliliters are in 1 liter?
100?
1,000.
1,000. So remember back in probably, grade 2, you had these blocks, these unit blocks, and then you had the 10 stick,
Yeah.
and then you had the 100, which was like a flat square with 10 by 10, and then you had the big box that was 10 by 10 by
I missed
10.
those.
Okay, that is 1,000. Pay attention. That big box is 1,000 cubic centimeters. Okay, 10 across here, 10 across here, and 10 deep. There's 1,000 cubic centimeters in there. If you were to carve that thing out or take off the top and fill it with water, it would be exactly 1 liter. Okay, so 1,000 cubic centimeters fits 1,000 milliliters, right? 1,000 cubic centimeters would fit 1,000 milliliters, and 1 liter is 1,000 milliliters.
So we have
Okay? So here we go.
1.96 liters,
So
right? And
the capacity, is how many milliliters? If it's 196 cubic
196.
centimeters, then it's 196 milliliters. But we need it in liters. So how many liters is that?
1.9.
No, it's 0.19.
Why 0.
Because it's 1,000, not 100.
0.196 liters. So basically what you would have to do is you'd have to take this number, divide it by 1,000. Okay? Which is 0.196 liters. Not enough to quench your thirst, really. Well, it would be. It'd be like a little glass. Yeah, a little more than half a cup. Yeah. Here we go. Okay, example 3. Surface area and volume of a triangular prism. This one's a little bit more straightforward than the pyramid. You guys ever eaten a Toblerone bar?
Yeah.
Okay, Toblerone bar comes in the shape of a triangular prism.
Never.
Oh my, this is so good.
And
Actually, you've had it.
regroup,
That's so bad.
I did get
regroup. Hello. You have a diagram there of a Toblerone bar. Calculate the amount of material required to make this box to the nearest square centimeter, then calculate the volume of this box. So the amount of material, what's that asking for?
The amount of material required to make the box.
Yeah, so using our math language,
You need to find the surface area.
so find the
Aha.
surface area of the box. Find the surface area of the box. All right. What are we going to do first?
You have to find the surface area.
First, so we need the surface area. In order to get the surface area, what do we need? What parts are involved? Okay, how many bases are there?
One.
So we're going to have 2 times the area of the base.
What?
And how many lateral faces are there?
3.
There are 3 lateral faces, so we're going to have 3 times the area of a face. Okay, we can't solve that right off the bat. We're going to need to do some side work for the area of the base. Why is that?
Because
It's a
it's
triangle.
the triangle.
No.
That's
We
what
don't
the
know
Greeks
height.
did back in the
We
day.
don't know the height of the triangle.
That's what we're
That's
doing.
what the Greeks.
Ah, okay, so for area
Jenna.
of base, we need the height. So you go ahead and draw a little diagram that's going to help you. Everyone is on their last warning. Draw a little diagram that's going to help you get the height of the triangular base.
Well, I don't know.
The height of a base.
So there's the triangular base. Hopefully you've drawn a triangular base.
Wouldn't the rectangle be bases at the bottom?
No, the rectangles are the lateral faces of the triangular
We
prism.
need the Pythagorean Theorem.
We will need the Pythagorean Theorem. Do you know what the
Wait.
lengths are that you have?
Wait. We
Three.
can't use the
And
Pythagorean.
Yes, we can.
So you have 3, and
You have
what's
to figure out half.
what's the length? 1.5.
Oh, I love the Pythagorean Theorem.
There's our square corner. Okay, go ahead and set up your equation for the Pythagorean Theorem. Be careful, you have the hypotenuse. You don't have one of the legs.
Minus 6.
That's what the Greeks did.
1.
B squared. Well,
Oops.
3 squared. Come on.
9 and 1.5 squared.
Can we do it by ourselves?
You are doing it by yourself.
Oh, I thought you just meant like the setup. Okay.
If you've gotten the height, you can check the board to see how you're doing. If it's wrong, you need to go back and correct it and think through it. If it's correct, you can keep going. Now you need to think about how you're going to keep going.
I didn't know how to read or write or read it.
Okay.
Do you always round to the nearest tenth or 1?
Well, the answer is asking for the nearest square centimeter. So yeah, in our in-between work, we'll round to the nearest decimal. Always leave one more decimal in the in-between steps than it requires in your final answer. Okay, that way you won't round too early, you won't lose any information. So now I'm just going back to my equation for surface area that we already established at the beginning. And I'm going to get the area of each base, the area of one of the bases.
When should the multiply?
No check.
Oh, sorry, I'm doing the wrong thing there. That was one of the lateral sides. So yeah, we're taking the area of the base, which is base times height divided by 2. And we're going to add 3 times the area of a face.
Where'd you get that from? Oh.
And now that we have all of our values, we can just do the math on it. My first step here in my head, I would just say 2 times a half is just 1. So this whole thing just becomes 1.
I thought it was 3 times.
Nope.
This is the base. This is the triangular parts. There's 2 triangular parts. Okay, and then we multiply 3 times 2.6, which if you have your calculator out, 7.8. And then this part over here, 3 times 3 is 9 times 12.
36.
108. Add those guys up. Gives us 115.8. Now our final...
By 2 and then times it by 2?
I just did this in my head. half of 2 is 1. 1 times anything doesn't change anything, so this whole thing just becomes 1.
I always
Why
get
do you do
confused
that?
with the fraction.
What do you mean?
Why did you write the 3 times 2.6?
Here?
Because the 3 is
It's
is
2.
the
It
base.
has to be 2 because there's not 3 triangles.
Okay, we have our our surface area. We have it rounded to the nearest tenth. We don't need that. We need it, what does our final answer need to be in?
Square
The nearest square centimeter.
50. 160.
16.
So the surface area is approximately 116, what's the units? Centimeters squared. Centimeters squared for area, yeah. Okay, let's move on to B. So now we have the volume for any right prism. So a right prism is just one where the base and the lateral faces meet at a right angle. Okay, so if you were to stand this Toblerone bar up on its edge, you would see a base and you would see a lateral side. Okay? Does that make sense?
Mm-hmm.
You see another lateral side, and then behind there would be the triangular. Yeah? Think we got it? Good. Okay. So it's pretty straightforward when we're calculating the volume of a right prism. It can be found using this formula. The volume is simply the area of the base multiplied by the height. Okay, so we're just taking the area of that square base and multiplying it by however tall it is. Make sense? So, here we go. What's the area of the base?
3.
So the area of the base, let's figure this out. So the area of the base is the area of the triangle, okay, which is right here already, 1/2 times 3 times 2.6. Okay, but this 2 is out here for surface area because we needed 2 times the area of the base. But now we just need the area of one of the bases of the triangle, so it's 1/2 times 3 times 2.6.
3.9.
And we're going to multiply it by the height, which is 12. So we can just plug that whole string into our calculator. 1/2 times 3 times 2.6 times
I
12.
don't know how to
I thought
calculate
it
it when
was
it
a
just says
third.
half.
I thought it was
You do the multiplication and divide the following.
Oh,
Area of a triangle is 1/2
46.8.
base times height. So altogether, 46.8. And finish it off with a statement.
C and
What did we find out in B?
cube.
The volume
The volume
is
of the box.
about, and I'm rounding to the nearest centimeter, cubic centimeter, 47 centimeters cubed. Okay?
Right.
Please ask any questions that you have right now.
I don't know.
Okay? Be careful. Make sure you know what you're dealing with. Use the right formulas. If you're not sure the right formula, ask or look it up or Google it. Okay? Sam.
so if there's a 1/3 in the beginning, do you just do all the multiplication and then divide by 3? Can I
You could do that, yes. Okay? But if it's like this situation, you have to make sure like this was divided by 2, but you didn't do the whole thing and then divide by 2. Right? The divide by 2 is on this side.
Okay.
Okay, that only works with multiplication. Your practice problems for this lesson are from page 416, 1 through 20, and then 430, number 1, 2, 5, 6, 9, and 11.
Said the